question 1, before we start with drawing the structure, then we need to find the oxidation state of metal center, and we have to list down all the charge of ligands. So for question 1a, list down the ligand as below. Since we want to find the oxidation state of titanium, so we left it unknown. We have chloride, -1, cyclopentadienyl, -1, and carbon monoxide is 0. So let's do simple maths to find oxidation state of titanium. So at the end of the calculation, we will get the oxidation state of metal central is +3. For question 1b, we still do the same step, which lists out all the charge of ligands. We have two types of ligand here, which is phenylethene and trimethylphosphine. So the charge of phenylethene is -1, meanwhile the trimethylphosphine is 0. We will get the oxidation state of iridium, +1. So for the drawing, it should be in trigonal bipyramidal shape since it has 5 coordination number. For question 1c, again, we have to list down all the ligand with their charge. We have phenylethene, -1, we have propene, -1, and ethylene diamine, neutral. So the oxidation state of palladium is +2.
So the explanation for question 2 is, firstly, tetrachloroplatinate possesses 4 chlorine ligands which attach to the platinum. Since all chlorine atoms are the same, the trans effect also will be the same. Next, one chlorine atom is substituted with thiourea. Now, we will compare the trans effect of chlorine and thiourea. According to the trans effect series, the trans effects of thallium is more than chlorine. When the second compound reacts with chlorine, the chlorine atom which is trans to the thiourea will be substituted by ethylene diamine.
For question 3a, bicyclopentadiene chlorocyano-titanium is more stable than bicyclopentadiene chloroamine titanium chlorine because of Cn can accept electrons from titanium via backbonding and form a sigma bond with its metal center, which is titanium. The oxidation number of titanium in both structure is 4+, and both of the complexes also have 16 electrons, and this structure geometry is square planar. NH3 in bicyclopentadiene chloroamine titanium chlorine cannot form a backbonding with titanium due to its nitrogen atom only have one lone pair, and NH3 only can form a pure sigma bond. So bicyclopentadiene chloroamine titanium chlorine is unstable. For question 3b, the oxidation number of iridium in both of the complexes is 1+. And have 18 electrons. Both of the structures geometry is square bipyramidal. Tetratrimethylphosphine phenylacetylene iridium is more stable than tetratrimethylphosphine methyl iridium due to its pi backbonding of the phenylacetylene. So the triple bond in the phenylacetylene make the complex become very strong compared to the bond in methyl.
For questions 4a, we can find the effective atomic number by using the formula EAM equal to Z minus X plus Y, which is Z is the atomic number of the metal center atom, X is the oxidation number of the metal center atom, and Y is the electron shared by the ligand. So the atomic number of the metal center here is 79, and the oxidation number of the metal center atom here is +1. and the number of electrons shared by the ligands is 2. So 2 multiplied by 2 is 4 because there is 2 ligands, and the effective atomic number is 79 minus 1 plus 4 equal to 82 electrons. Same goes for question 4b. We use the same formula, which is EAN equal to Z minus X plus Y. So the atomic number of the metal center atom here is 77, and the oxidation number of the metal center atom is plus 3. The electron shared by the ligands is 2 multiplied by 6 equal to 12. So the effective atomic number for this complex is 77 minus 3 plus 12 equals to 86 electrons.